Alright, we're on 5.1. If you look at chapter 5, the beginning of it, so flip over to page 204. It says algebra on it. All algebra is, first of all, when we hear the word algebra, what do we think?
Letters?
We think about it as harder. Our brain scrambling.
Brain scrambling, okay. What else? Yeah?
Letters used as numbers.
Letters used as numbers? What if I told you you guys have been doing algebra since you were like 2 years old? What?
Equals 2.
Congratulations, you guys all know how to do algebra.
No, I don't.
Yes, you do. You know what 1 plus 1 is, right?
Yeah.
1 plus 1 is 2. That's algebra. All algebra is manipulating numbers. That's all it is. It's just manipulating numbers, trying to see what things are at. Oftentimes it will have equations, sometimes it won't. If it has an equal sign, it's called an equation. If it has a, repeat after me, if it has a equal sign, it is an equation. If it has a
Equal sign, it has an equation.
it is an equation. If it is just 1 plus 1 and it doesn't have anything else with it, then it is an expression. It expresses something, but we're not seeing what it equals. So, all it is manipulation of numbers. Like you're using numbers, adding, subtracting, multiplying, dividing, all that other stuff. There's more as well. Yes?
Just like you have to find out what the letter equals to, and then...
So, very simple algebra would be like this. Unknown numbers are usually represented by variables. Variable, you should be writing this down. An unknown number. Examples. What is the most commonly used unknown number or variable? An unknown number represented by a what? By a what? You guys said it before.
A letter.
A letter. I want this over here. No? Okay. A variable is an unknown number represented by a letter. So, an example of that might be, let's say, 3 plus, what's the most commonly used unknown number we said?
X.
Yes, x. X is the most common one. 3 plus x equals 5. What's x?
2.
2, right? And you look at this, and you say, hey, I can solve that, right? Now, how did you solve it? Yeah?
Because 3 plus 2 equals 5, and x obviously has to be 2.
Yeah, so that's the short way. Your brain automatically knows how to do it. Here's the way I'm going to retrain you to try to think about it, because if you think about it this way, it will be harder in the short term. Not a lot harder, but it will be a little bit harder in the short term. In the long term, it will be much easier. So, what the step I'm going to try to teach you is that, again, you're going to want to write this down. To solve an equation, which means numbers, letters, equal sign. So right here, all of those things are right here. It's got a number, it's got a letter, it's got an equal sign. That makes it an equation. Technically, you don't even really need the letters. You could say 3 plus 1 equals 4. That's still an equation. It's got a number, it's got an equal sign. That makes it an equation. But to solve an equation, solve means what?
To figure out.
Figure out and get an answer for, or get an answer for. Carson, if I hear one more sound out of you, you're done. To solve an equation, undo what is being done to the variable. Alright, copy that down. Give me a thumbs up when you're done. I'll give you guys about 10 more seconds. Are you taking notes or are you looking at it? Not a good choice. Try again. Undo what's being done to the variable. Now, we might not know exactly what that means right away, so let's explain it. Let's go back to x plus, or no, what did I say? 3 plus x equals 5? 3 plus x equals 5. What is being, first of all, what's the variable here? X. What is being done to x?
It's a 2.
It's what?
It's a 2.
What is being done to it though? It's not a 2, it being a 2. What? It's being added by 3. So what is the opposite of adding by 3? Yeah, because it said undo what is being done to the variable. So what's the opposite of adding by 3? Subtracting by 3. And whatever you do to one side of an equation, you have to do to the other. X equals what? 2. Now, did we already know that?
Yes.
Was this like complicated to do?
No.
No. But why would you not just do this automatically based on what you knew before? 1, you didn't know how to do it, and 2,
Yeah, sure.
okay, that's true. 2, you already knew because you knew 3 plus some number is 5, right? You know that answer is 2. Now, for this type of equation, you might think, hey, that's not important. But where this will come in handy is if I say 3x plus 4 in parentheses minus 2 times 5 equals 200. Well, using this simple thing with maybe 1 or 2 extra things added on, this becomes pretty doable. You can't do this in your head. Maybe you can think, hey, that's 10, 3x plus 4, but then you have to think, hey, well, I've got to add the 10 back onto the other side, I got to subtract this 4 off, I got to divide by 3. You guys don't even know all those rules yet. But those simple other rules added in there. So what I want you guys to do is when you see this, do the thing that makes it a little bit harder now so that in the future it doesn't become as hard. Show your extra work with it. Yes, I realize that you feel like, hey, I'm doing all this little extra work that I already know how to do all this stuff right now, but I promise you it will be worth it in the long run. Because if I had $1 for every student who said, I already get this, I already know how to do it in my head, I don't need to show my work, and then they stuck their chest out like that. Okay, most of them don't stick out their chest like that. But if I had $1 for every time I had a student who did that, I would have a lot more money than I have right now. Because it comes in all the times where students are like, hey, I already know how to do this. Because like a 3rd grader could come in and do that, right? Well, what they can't do is the stuff that you guys are going to learn. Are you done?
No.
Okay, you're going to have to wait because I'm in the middle of a lesson right here. All right, let's go to page 208. A. Can I have someone read A for me? You ready?
Randy is
read A.
Write an expression to show Randy's age 1 year from now.
Remember, what did I say is the difference between an expression and an equation?
Equal.
What, Jameson?
Equal sign.
What about an equal sign?
If you don't have an equal sign, it's an expression. But if you have an equal sign, it's
Correct. So it said write an expression for Andy's age a year from now. That means that right now his age is how old?
12.
And we are at 1 year from now, how old is he gonna be?
1. I'm at 12. 13.
13. So if I just say one number, that's not an expression. An expression means I've got addition, subtraction, multiplication, division, those things in it. So I've got 12. Another year from now means I'm going to do 12, what?
Plus 1.
12 plus 1. And then if I were to turn this into an equation, I would say 12 plus 1 equals 13. Expression, no equal sign. Equation, equal sign. B, can someone read B for me? You can switch Randy's name to something else that's cool. Go for it, Jordan.
Ray. Oh no. Randy's. No, hold on. Bryson's age 1 year from now is 12 plus 1 or 13 years. What an expression to show Bryson's age 2 years ago.
Okay, so this was A. Let's go B. He's 12 years old right now, so 2 years ago he would have been.
10.
Well, what's the expression for that?
10. 12 minus 2.
Yep, and the equation for that would be.
10.
Nope, that's not an equation. Doesn't have an equal sign.
12 minus 2 equals 10.
Good. And you can look at there. It tells you what to do with it. Next page, 209. Use variables to represent unknown numbers and form expressions involving addition and subtraction. Mr. Bernal is a 5th and 6th grade teacher. His students do not know his age.
27.
Aw, man. A, David, can you read that for us? We're on page 209. I need you to follow along.
Write an expression to show Mr. Bernal's age 1 year from now.
Okay, expression, remember? I'm just going to put EXPR for expression. What is my age right now?
27.
What is it according to what the book said?
Eh.
We don't know. If we don't know the age for something, then we do what with it? We assign it A, or we give it A.
Yes.
You don't know what it is. It is an unknown number. It is an unknown number. What do we give it if it's an unknown number? We give it a letter. What letter do you want to give my age?
X.
X? You're going to be boring? No, I refuse. Y? That's the next most commonly used one?
No.
You're boring. That's not a letter.
Z. A.
A. Okay. So my letter is A. My age is 8 years old right now. And 1 year from now, what's the expression for how old I am? 1 more year from now.
28.
No, because we don't know how old I am, remember?
A plus 1.
A plus 1. Can we write this as an equation?
No.
Why not?
Because you're not supposed to have the equal sign yet.
Why not?
Because you have an unknown number.
No, I could put it, if I knew what my age my year would be a year from now, then I could do that. Let's say it's not me. Let's say it's a different teacher that you have, and I say, hey, his age is, you don't know what his age is right now, but if you 1 year from now, he's going to be 32. How would you figure out how old he is? Yes?
By subtracting the 1 from 32.
Well, the goal is to get the variable by itself, or to solve for the variable. So remember what we said from right here. What do we have to do to this side? Because we want to get the variable by itself. Everybody, get the variable by itself. Repeat after me. Get the variable by itself. Yes?
Whatever you do to one side, you have to do to the other.
So what do I do to get the variable by itself over here?
You do 1 subtracted by 1.
1 subtracted by 1.
No.
A subtracted by 1.
Kevin, Braden, no. You cannot help each other because you are talking about other things and messing around.
Okay. A subtracted by 1.
It's not a subtracted by 1, it's just this plus 1, you subtract 1 off of it because you want these to cancel each other out. Whatever you do to one side, gotta do to the other. So a equals 31. So what age is it? What age is this a teacher?
31.
He's 31 years old right now. Because we said the unknown number plus 1 year from now, is 32. So we don't know the teacher's age right now, but 1 year from now, the teacher's going to be 32.
That makes sense.
What's up? Okay, well, you don't know what his age is right now, right? But you do know if you add 1, it equals 32. If I told you that hey, here's your teacher for next year, and I can't tell you how old he is right now, but next year he'll be 32. How old is he right now?
31.
Yeah, so what you did is, as an equation, we said, hey, we have the unknown number, a, we're adding 1 to it, because that's next year, and we know that next year he will be, or his age is going to equal 32.
Where'd you get the 32 from?
I made it up. Because this isn't, your actual teacher, that's not his age, I can tell you that for a fact. But if I add, I'm just saying hypothetically, if you add 1, it would be 32. So to get rid of the adding 1, you need to subtract 1, and whatever you do to one side, you gotta do to the other. This is, remember how I said it's slightly complicating it? Because you knew right away he was 31 years old, right? You knew right away, because you know what number plus 1 is 32? It's 31, right? 31 plus 1 is 32. But this is hey, we're making it a little bit more complex in the short term so that in the long term, you know how to solve equations better. Because this is about the most simple equation in the world.
I was just confused because I walked over there and then I sat down and the 32 just appeared there.
Oh, okay, I don't know. Yeah?
So, when you cross that off, where do you get that from?
Where do I get it from?
Yeah.
It just means, so I cross it off because when you're done there, like what's 1 minus 1?
0.
So basically that means it turns into a plus 0 equals 32. Do you need to represent the 0 there?
No.
No, so it's like you cancel it out. It's the same thing as when we have something like, let's say I have 3 over 4 times 4 over 5. Well, I cancel these out and they're gone, right? Now, are they actually gone? No, they represent 1. But do I need a 1 if I'm multiplying fractions? No, I can just say it's 3 over 5. I don't need to say 3 times 1 over 5 times 1 because it's already implied. Same thing, when I have a by itself, I don't need to say a plus 0. I can just cancel it out and it's gone.
Is it because if I know you made up the random number of 32, it would have been 31 because if you subtract 1 from 32, it'd be 31. So it's like almost no point of having the 1 there.
Well, if I didn't tell you that out loud, and I just said, hey, this expression represents how old your teacher, this expression right here, represents how old your teacher will be 1 year from now, and then I told you after that, so that would be the expression a plus 1 because you don't know, you don't know, and then I said, hey, your teacher is 8 years old right now. He will be 1 year old. In 1 year from now, he will be 32. This would be the equation: a plus 1 equals 32. And then we go back to what we know about equations and expressions, and how we have to get the variable by itself or to solve for the variable. We have to undo what's being done to the variable. What's the opposite of adding?
Subtract.
1, subtracting 1. So we subtracted 1 from one side. Whatever you do to one side, gotta do to the other, and you end up getting 31. Yes?
Can you just make up any random number?
You can. Yes?
That's supposed to be an 8 or a 9.
An A. My A's and 9s are sometimes a little bit confusing. Sorry about that. Oh, that's not what I wanted. That's boring. Teacher email, are you kidding me? We love spending lots of extra time on email, actually. B, can someone write B there? Read B there. Carter.
Okay. Muffler?
No, read B.
Oh.
If you're gonna pay attention, you need to take out your book. Unless your book is in your desk, in which case, no.
Write an expression to show Mr. Haskins' age to 2 years ago. Use the same variable x.
Yep, so right here, on there it says, now he is X years old, or let's say A years old. And 1 year ago, he would have been how old? Not A years old, but A.
31.
Nope, because this doesn't say, we're not saying how old. That 31 number, remember, I made up that number, it is not in the book. We're going back to what's in the book right now. It said, write an expression for how old he was 1 year ago. If he's 8 years old right now, how old would he have been 1 year ago?
He's 30.
No, I just said, do not use the 30 number. I made up that number, it is not in your book. We're going back to what's in the book. Just in terms of A. So he's 8 years old right now. You have no idea if A is 30, 40, 12, 17, you have no clue. If he's 8 years old right now, how old was he a year ago? Is it more than A? Is it less than A?
Less than a.
How much less?
1.
So how would you say that? You would say
Negative.
A minus 1. What about 2 years old? 2 years ago, how old would he have been?
A minus 2.
A minus 2. Now, if I tell you, hey, your teacher is 40 years old, if I tell you your teacher was 40 years old 2 years ago, then you can do this, and you can solve for the variable,
42.
which means he's 42 right now. If I told you that, but I'm not telling you how old he is. So, if I just said, hey, he's 8 years old right now, write an expression for how old he was 2 years ago, then you would say, Mr. X, because you don't know his name, Mr. X was, oh, that's supposed to be an S, A minus 2 years old 2 years ago. And that's what you would write. Now, why did I put these in parentheses? Yeah?
Because whenever like you're gonna say something specific, or like to answer something.
Kind of. Basically, the big reason is, think about it in terms of this. Let's say that I have something I say that Jordy is 11 years old. Okay? I could also say Jordy is 5.5 times 2 years old, right? So here, when I do that, when this you have multiplication right here, or you're just saying it, the label goes right on next to it. But if I said Jordy was 12 minus 1 years old, now I need to put parentheses on it. Because the thing with addition is, addition and subtraction, anytime you have addition or subtraction, then you need to put the label in parentheses. Because if you don't want parentheses, then you need to say 12 years minus 1 year. Because otherwise you need to show that the years is going on to each one of them. If you put the parentheses, that means everything inside the parentheses, it applies to all of it. You guys remember when we did order of operations? Have I done order of operations with you guys yet? Like addition, if you have 3 times 4 minus 2 times 6. So when you have operations like this, multiplication has to come, multiplication and division you do first, and then you do addition and subtraction. So multiplication first, this becomes 12, this becomes 12. You have to do both multiplications first, then you can do the subtraction, and you get 0. If you weren't doing your order of operations and you just went left to right, you would do 3 times 4, which ends up being 12. You would do 12 minus 2, which ends up being 10. And you do 10 times 6, which ends up being 60. This is the real answer. This is what you would get if you were doing your order of operations wrong. And you're just going straight up left to right. It's not, so that's kind of the long answer. I realize it might not totally make sense, but the short end of all of it right now is if you have addition or subtraction for your expression, then it needs to be in parentheses when you put a label on it. If it's multiplication or division, then you don't need to put a label on it. All right. All right, page 210. Let's do this table first.